Previously, we had used this inventory model to calculate the economic order quantity for one of the products in the sales data set, and in that case it was product D. And we had come up with the annual demand using the forecast. These other assumptions were provided, and we set up this cost model and used Solver to find the economic order quantity, which was 464. Now what we're going to do is consider the case where either the daily demand or the lead time is uncertain. And so we've got some other assumptions to fill in here in the inputs section. First of all, the standard deviation of daily demand we're going to estimate from the forecast data. So we have a forecast here for product D. This forecast was created as a weighted moving average, and these were the weights that were selected for the forecast for product D using Solver. Now, one of the error measurements that we measured was the mean squared error. And this is kind of like a standard, a variance in a way. And so if we were to calculate the square root of the mean squared error, that's a number that we call the root mean squared error, RMSE. Now, this is a monthly root mean squared error because this is a monthly forecast. And so in this data set, we're assuming that the working days per year is 300, and because there are 12 months, what we're really also assuming is just that there are 300 divided by 12, or 25 days per month, approximately. So if we want to turn this root mean squared error into an estimate of the daily standard deviation of demand, what we can do is just divide this 125.967 by 25. And we'll just call that the daily standard deviation for demand. Demand is what we're estimating with this forecast. So we'll just reference that from over here. Or you can type it in as 5.04. When I referenced it, I got an integer number, but if I expand the decimals, you can see it's about 5.04. Now, the other uncertain factor in this model is the lead time. The lead time is the time from when we place the order to when the supplier delivers the new inventory. And this can be estimated maybe in different ways, but in this case, in the product sales data, there are some sample results for different lead times with this supplier. And so if we go over to this product sales data file, there's a tab here called LT for lead time, and here we have the samples for lead times for the different products. So there are some samples here, some lead times for product D. So on actual historical orders, for instance, on one of the orders for product D it was 4 days, on one it was 3, and so on. So what we could do, just to make sure we capture everything that's product D here, we can insert a pivot table. And if we have the cursor somewhere in this range, we'll select that. There's only 2 columns. And so what we can do here is just add lead time to the rows. Okay. And actually, let's take it out of the rows. All we really want to do is we'll calculate not the sum of lead time. What we'd be interested in, if we go to value field settings, is the average of lead time. And then what we'll do is we'll put a filter here on product. And because right now we're dealing with product D, we'll go ahead and filter on product D. And so we can see there's our average of our lead time, and it's about 2.7. We'll just round that to 2.7 and enter it over here. Now what we could also do is just drag lead time down into the values field again, and then instead of sum we'll use this drop down value field settings, and let's now calculate standard deviation. And so for product D, we're still filtered on D. That looks like about 0.73. We'll just round that to 0.73. All right, and so now we've got all the assumptions filled in here. Okay, and so in terms of the lead time demand, here we have the lead time, and here we have a random variable daily demand. And so if per day we have 87 in demand, approximately, and our lead time is 2.7 days, then the lead time demand, in other words, the number of customers who want to buy after we order, but while we're waiting on our inventory, would just be the average daily demand times the average lead time. And I've entered this round function just to round this to an integer number. It'll make some of our other calculations easier. So on average, our demand during our lead time is 236. Now, the standard deviation of lead time demand is a little bit more complicated. If we put our cursor up here after the formula, we'll see, though, that four things affected. It's affected by both the mean and standard deviation of daily demand and the mean and standard deviation of lead time. Let me hit enter for a moment, and just remember that here we have 5.04 and here we have 0.73. Let's suppose for a minute, I'm going to put those out here just so I remember what those numbers were. If we were to change those to 0, just momentarily, we can see now there's the standard deviation of lead time demand is also 0. In other words, it's certain. If we suppose that our supplier is always reliable and delivers our inventory at the same average and the same number of days each order, then we'd be only dealing with one source of uncertainty, and still the lead time demand is pretty small. But even though the standard deviation of lead time demand is only 0.73, if we put that in here, the standard deviation of lead time demand grows quite a bit. So that's why we need to factor this in. Now, we're assuming that the lead time demand has a normal distribution. And so in a normal distribution, about 3 of the standard deviations captures 99% of the probability. So what we can do to calculate the maximum lead time demand is take the mean plus 3 times the standard deviation. And that's 428. Now, on the tab called LTT distribution, there's a picture of this normal distribution. It has a mean of 236, and we can see that out here at the very end is about 429, which is what we calculated and called the effective maximum. We'll return to this picture in a minute. Alright, now we'll discuss what we mean by desired service level, but for right now we're going to enter just a number 90%, and then later we'll use that as the target. The reorder point is what establishes something called the safety stock, which is extra inventory that is around in order to buffer against uncertain lead time demand. For the moment, let's just put in 300 as a starting point. We're going to let Solver change this value. And so the additional, the reorder point minus the mean lead time demand is what comprises the safety stock. Now, the service level at the optimal solution is the probability that an order is filled on time before we have any stockouts. And so that would just be the area under the curve up to the reorder point. And so we would enter the reorder point in our normal distribution. We'll enter our mean, our standard deviation, and then the 1, we can either click true or type 1, and that means we want the cumulative probability up to that reorder point. And we'll look back to the picture when we get a solution. We make one other adjustment to our model, and that is we'll go ahead and reference here in the holding cost the safety stock, because holding this extra inventory as safety stock is going to entail more holding cost. And so that means that we would need to adjust our formula for the holding cost to include not only the average inventory, but also the safety stock. So we'll multiply both of those times B12, which is the holding cost per unit. And everything else in our model can stay the same, because this annual inventory cost still references the total holding cost. Now what we need to do is modify Solver so that it chooses both the order quantity and the reorder point. So if we pull up Solver, we've got to make a few changes. We've got the same objective, but now what we need to do is have two changing cells. And we want to choose this reorder point so we achieve the desired service level. So we need to add a constraint. Looks like I've got a mistake on my objective cells. Okay. And we need to add a constraint that the service level is greater than or equal to the targeted service level, which we entered here, and we can change and experiment with that. And so we'll go ahead and click Solve. And what we find is our reorder point of 318 will give us now a service level that's 90%. In terms of the picture, this shows the reorder point that achieves 90%. And so we have here a 10% stockout rate, and actually this label on service level should say 90%. But this reorder point is what provides a stockout rate of 90%, and the service level is the opposite of the stockout rate. And so that's how we can adjust our model to set a reorder point to achieve a desired service level. You can experiment with different service levels, and that will give different costs and a different reorder point.